Okay, part 5. Uh, this video is going to cover a very brute force type of way to move your data to somewhere else to visualize. Perhaps if you're going to prep it for statistical analyses or just visualize it in Excel. Perhaps you like to just create the figures there or organize all the trials that you've collected for an individual. This is not a way that I'd recommend doing this, but it is a way that I think introduces you to why you might want to look for more elegant ways to organize your data. And we'll get to that when we do multi-trial strategies for this, looking at multiple trials at once. But right now we're looking at one trial at a time. And so what we want to do is just export that and just paste it over to Excel. Okay, now again, this is brute force. If you're familiar with Matlab, again, I don't suggest you start doing this and use this as your method, but it's just a way to start thinking about how to do it for visuals and then how to do it in a more streamlined fashion. Okay, so again, we're starting here. We've got all our variables calculated. I added a few that we didn't cover for redundancy for the landing. That's beside the point. What we're going to do now is create a visual. Now I know we've created a lot of graphs thus far and just inspected some quick graphs and showed you in I think the first video how to create a figure and kind of get it going. But you may want to create different types of graphs. You might want to create a bar graph. And so what we're going to do is cover how you might want to look at a bar graph perhaps of your performance variables for this person. Okay. To do and create bar graphs, we're going to have to take these individual single data points. So for instance, the example we'll use for this will just be for jump height. So we'll use, for our jump performance variables. So let's make a note there. So what we're going to do is create a variable, and let's just call it jump performance. And now to do this, what we're going to do, because we're going to combine multiple already set variables, we're going to open a bracket, and we're going to type jump height. Type it. Let's do, well actually before jump height, let's keep them in kind of a associated place. We'll do our jump momentum, we'll hit a space, we'll do jump height, but we have to type it in exactly as the variable is. We'll then do RSI mod, and we'll then do jump time. So those are the variables I used above. Where are we at? Here for performance. Actually, if I wanted to make this more correct, I'd do this. Because jump time, I think, is a performance variable. We'll organize it that way. So we've got our 4 variables. Now when I do this, what we'll create is a jump performance variable, a new one, where is it, HIJKL, that has each one of those variables in it. Okay, so we've got our momentum, we've got our jump height, we've got our RSI mod, and our jump time. Now what I can do is simply type bar and do jump performance and paste this in. You'll see, and we'll create in our figure, whoops. Let's do this one more time. Variable here. Now you look and you go, oh, it's problematic because momentum is so ginormous. Right? You see that variable, and it kind of ruins how this would look. So you may end up wanting to do this as a subplot. So what we would do is take momentum out of here. Okay, and what we would do is do a subplot like we've done before. And subplot, let's get that line out of the way. We'll use 1 row, we'll use 2 columns, and this will be figure number 1. and we will bar momentum. Okay, so if we want to see what that would look like, we'll have our figure, and over here in that first bar is just momentum. Now ideally we would have a variable that might have a similar unit of measure there. For instance, if you're going to use like a net, well, beyond the point, you get the idea. There's momentum there. We can add our y label and put the units kilogram meters per second. Right. And there's our unit there. I can give this a title and do this as takeoff momentum. And if I were to run that, there you see it, takeoff momentum. Okay. It defaults here to this little number. We can change that to put our text variable in there that we want this to be. We don't really need to do that here for this little quick visual. What we will want to do here now is create our new graph of the other variables that have similar unit or similar absolute values. So now we're going to do a subplot. It's going to be one row, two columns, but now it's a second graph. And what we're going to do now is bar jump performance. Okay. Now this is going to paste that in here and add that. Oh, I left momentum in there because I didn't change it. So let's go up here. Let me make sure I run this line after I remove momentum from it. Then what I'll do is rerun that subplot. Okay, whoops, created that, deleted my figure. So if I do the whole one again, there you go. Now what I don't have here are units. Instead what we can do is give these the names that we want them to have and give them the units. What we, oops, don't want that up. What we want to make sure we add here is a title to the top and units. Okay. So let's go ahead and do that here. So we'll go right here and we'll do Y label. Well, we don't need Y labels yet because they're going to be unique units. So we'll end up actually doing title, and we will do, well, let's actually give them, perhaps if you wanted to do this simply, you could do jump height because we know that's first and give it a 1 in the title. Do RSI mod, give it a 2, so something like this. Right, so you could, brute force your way through, do something like this. If you maximize your figure, that's no problem, right? But that may not be something we're really interested in. All right, so because that's not really a clean, crisp process, let's go ahead and try to give these names. So what we'll do is perhaps let's call these labels. Okay, what we're going to do is open a squiggly bracket, and then within that squiggly bracket is type those variables. So this first one is jump height, and I might give it their units, right? Then I might do a space and do RSI, oops, a space with a single quote because we're typing text, and do RSI mod, no units, right, because it's arbitrary. And then I might space and do another single quote and do time with seconds. Close my squiggly bracket. What that's going to do is create, what did I call these, labels, right? A text variable, or what we would call a cell variable, is what we created formally, but it has each one of these names within a specific column. And what we're going to do is add those labels to the graph. So in order to do that, what we're going to do is set our xtick labels. So this is kind of a unique command where we'll go with set. In the middle, we'll do GCA, which means kind of, I forgot the graphic something something, but it's essentially the qualities of that figure. And the specific quality we're going to work with is, oops, xtick labels. Okay, in a single quote. And then after we do that, we're going to do a comma and put labels. Okay, now it's been a minute since I've done this, so we'll see if that works without error. And boom, it worked. All right. Now you'll notice the way that I typed in that word, I used an underscore. That underscore makes the next value here a subscript. So you see it's RSI little m mod. So what we can do, let's go ahead and just get rid of that. And redo it. Right, so you're getting a little more creative here with the figure. Now, if we wanted to, realistically, I think this would work. I haven't done this before, but let's go ahead and try it. If I went ahead and put momentum back into the jump performance variable, right, and then I didn't do a subplot, but I wanted to bar jump performance. Now this might not work, so if it doesn't, we'll just quickly move off. But we'll bar jump performance. Okay. Remember, everything's kind of messed up over here. But what we're going to try to do is send the axis to the right and then rebar those other variables, but without, kind of like barring a new set of jump performance variables, but without momentum. So if you wanted on one graph with momentum here and the other units here, hopefully this will work. And again, I'm just experimenting here. So what we'll do is bar that jump performance method. Now what we'll do is we'll just do this in the command window so it's clear that, so you can see what I'm going to do is hold on YY axis, we'll move it to the right, and we will create a new variable, and let's just call it jump performance 1, and let's make it a nan, so this is not a number, it's blank, and then we'll do jump height, RSI mod, jump time, so it still has 4, so it's going to essentially plot nothing on top of momentum and then plot those other 4, and let's just see if that works. And now if I were to bar jump performance 1, let's see, I don't know if this works. Moment of truth. Boom! It worked. Okay, so that would work. Now what I would need to do is modify my labels to include momentum. And then I might give it kilogram meters per second units. All right, so I've just simply redone my labels, and now I'm adding those X tick labels to the figure. Okay, maximizing, you can see I've got it there. Now what I would do is add my Y label here, which we've done before, and my X label to the other side. Now when I graph these, right, I can specify a color when I bar these. So like if I bar jump performance 1, I can specify that they're blue. Right, and it will kind of match those colors better. Or I could, in the first graph, when I barred momentum, is made it blue, and then all those colors will match, right? And then after I've done my labels and added my unit values, you'll have all those variables. So just if you wanted to create a different type of visual we haven't done yet, creating bar graphs, you can really get creative with bar graphs. And again, this is just scratching the surface, just playing around with it. Obviously not something I would use in a formal presentation or document, but just toying around with what Matlab can do. All right, so once we've done that, let's go ahead and clear the command window because it's frustrating having all that in there. And let's export the data. This will be where we'll have the variables go out to it. Now, ideally, you'll export every variable you have. So if you think of all these variables, we've got quite a few. I'm just going to show you an example with a couple so you get the idea. So what I do is create an export variable. I always put it in caps because it stands out in the workspace. And we create a bracket. Now I want this to be one row of a bunch of columns so that I can just grab it here and put it in Excel. For instance, you may have an Excel sheet where one worksheet is participant 1, the second worksheet is participant 2 or athlete 2, third is 3, and you just have all their respective trials in their own sheets. Right, so you can graph them and look at them there. So what I would do here is, let's say I'm just going to look at those jump performance variables we were dealing with here as the example. So what I'm going to do is I'm going to export that momentum. I'm going to use a space. That's going to move it over to the next column. If I used a semicolon, that would drop it to the next row, and we don't want to do that. So we're going to use that. We'll use jump height. We'll use RSI mod. And jump time. We'll close our bracket. Now this is going to create essentially the same thing we did for jump performance. So, we could have just withheld jump performance here. I'm creating an actual export because I want that to be unique to itself. Okay, and so there's those 4 values you'll see in here. I'll have my export, and that's there. The next one we'll do will be the export headers, because sometimes we might forget what those are. And so just like we did here for labels, we're going to do this same exact thing. Okay, so I can just copy this. And this is useful. The reason why I'm doing these redundant lines with new variables is because sometimes we might skip this little graph and not do any of that stuff and not have done that yet. And we've gone right to exporting. Right? So we wouldn't necessarily have had jump performance or labels made, right? So imagine that's the kind of scenario we're in. And so I'll do this. Oops, don't do that. I will copy that, paste it into the command window, and I'll have my export headers. So I know what the variables are. Okay. Now I could create a table in Matlab. It's kind of beyond the point, I think. But let me open an Excel sheet, put it here. We'll put Matlab here. And so what I might have is I'll create something for this participant. So like imagine this is sheet 1 for athlete 1, right? Here I'll have trial. And then export headers, I can click on it, I can grab the row, Control C, and come here and Control V, and I've got my variable names, right? Then all I've got to do for this trial is open export, copy, and go here, right? And I can do that for any number of trials that I have. So if I were to, let's just get rid of the visuals and take this. Now realistically, this script is written. So working with a single trial, it's done. Technically, what you would do is add more of your export variables so they'd all be in there. And you update your headers so that they would all match. But that was trial 1. So now what I can do is actually save this script, right? And I'll actually go into where I keep these codes. And I'll actually save as up here in Matlab. I'll just name it. Again, you can see my naming styles aren't very good. And so I've got the script run. So now what I can do is, remember I'm working with one trial here, but if you recall from the first video, if I go to my files, I've got 15 of these. So that's number 1. Okay. Now if I open up Excel again, I'll have 15 trials. I'll just do 1 or 2 of them here. Now what I can do, because this is all run, is just come up here and hit run on the script. Okay, it will ask me for where the data are. Remember, these are all things that we ran as a single line. Now we're telling Matlab to do all of these things in the script at one time. Okay, so it read that one trial, it calculated all my variables. Here's my export. If I were to put it right underneath what we did, right, same values. So even though it's not trial 2, it's there. Now if I wanted to run through trial 2, I'll just change this line right here. Remember in the importing trials, and we selected number 1, that was from the first video we did. We'll put that as a 2. I can hit run, go through the same stuff, find my file where the folders are, find my folder where the trials are, and go. There's my second trial. All right, I can do this again for trial 3. And you'll see how this just becomes a redundancy type of piece. Right, and you'll see all those variables are in there, and they're kind of in similar types, and that's how we do it. So you do all that for that athlete, you'd have your next worksheet for athlete 2, and then we can monitor these if you wanted to, create your, if you're an Excel grapher, maybe, I haven't grabbed an Excel in a long time. Wonder why. Oh, weird, because I'm minimized. Right, you want to graph your momentum in a different way in Excel. Sometimes it's easier to just whip them up here. Or if you're doing statistical testing, you might do your 3 here, have your average, and use your basic Excel skills to create your average. And then you might have a final sheet over here at the very end that's kind of, summary data, where it's the average for all athletes, and you'll have athlete 1, 2, 3 with your variables here, and then you just have the average pasted into here. Right? So it's one way you can do it. This is kind of brute force. This is requiring you to process a single trial, so if you're a newbie to Matlab and just getting into it, this may be the way that you want to do it. The one perk for doing it this way is that you can check every single trial individually right there explicitly in front of you without having to kind of programmatically get tricky. And then you can put it into a more familiar software program like SPSS or Excel for your deeper analyses, if you want to run correlations, or if you want to do do your analyses you may want to do. So that will conclude the single trial series. So we work with a single trial, but again, you can use a series of trials. You'll just have to do this process repetitively. And that ends the series. We'll move on. In the second series will be how to modify this or start from scratch, but doing the same process you did now, but so that it replicates itself automatically on all of the trials. Okay, we'll also do some more spicy things where we'll do some analyses and monitoring over time in that script as well. So we won't leave MATLAB for that next one. All right, see you next time.